Usually in tautology, we'll get all the results as true. If it is false, we can call it as it is a contradiction. P implies P or Q. You just check these two columns, P and P or Q column. Please understand the concept. If your P and Q is true, then P also true. P is true, Q is also true. Therefore, P and Q is also true. It is a valid statement. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, MYSURU. In my previous session, I have discussed some problems on tautology. So today I will discuss the concept called tautological implication. So what is this tautological implication? Tautology means the truth values which is always true is called as tautology. Usually in tautology, we'll get all the results as true. If it is false, we can call it as it is a contradiction. Contradiction means which is always false. Tautology means which is always true. And what is this tautological implication? A compound proposition A, P1, P2, Pn is said to be tautologically imply the compound proposition. So in tautological implication, all the truth values will be true. In tautology, all the truth values will be true. Example, I have one proposition here, P implies P or Q. So here, I will prove this with a truth table. This statement, this proposition is a tautology. So how to prove this? Here, I will explain this with the help of the truth table. I will simplify this. It is a tautology. We have two propositions, P and Q. Write the truth values, true, 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 false, false, true, and false, false. Here, first we have to find P or Q. P or Q. We are using OR operation, that is addition. If any one of the statement is true, we'll get the true condition in OR. So true, 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 and false, false is false. And finally, we have to find P implies P or Q. P implies P or Q. So what is the truth values of this statement? P implies P or Q. You just check these two columns, P and P or Q column. In implication condition, true, true means it is true. True, false is false. False, true is true. And false, false is also true. This is a truth table for implication, right? Here, if your first statement and second statement, you just observe this truth statement. If your first condition is true, second condition is false, then only the final condition is false. Otherwise, all the conditions are true in implication, right? So here, I will use these two columns for finding whether it is a tautology or not. True, true is true. True, true, true. False, true is also true. False, false is also true. So now, it is a tautology. Right? So, if we get all the truth values are true, we can call it as it is a tautological implication. So now, this is the table for implications. This is very important table. It is implications table. In implications, tautological implications, all the truth values should be true. Then only we can call it as it is a tautological implications. So all the truth values should be true only. Here I have 12 propositions. So any one of the propositions you can find. All the propositions will get the truth values. All the propositions truth value is true only. You can prove this with the help of truth table. You can prove this is a tautological implications. So these are the implications tables. You have to remember this while proving the problems. So first I will take one example. Here I will take the fourth example. Negation P implies Q. Here I will prove this is a tautological implication. So I will prove this with the help of truth table. True, 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 false, false, true, and false, false. So first I will find out negation P. What is negation P? True changes to false, true to false, false true, false true. And P implies Q. P implies Q means true, true is true, true, false only, false, false, true, true, false, false, true. So now I will find out negation P implies Q. Here I will use only this negation P implies Q column. False true means it is true, false false is true, true true is true, true true is true. So it is a tautological implication. So all the truth values should be true only. Then only we can call it as it is a tautology. So you can take any other examples here. We have 12 propositions. If you want, you can find out any other propositions. All the propositions is tautological implications because all the truth values are true only. You have to remember this implications tables. And next topic is logical implication. So what is this logical implications? Already in my previous session you learned the logical equivalence, right? So here we are learning logical implication. Logical implication is a type of relationship between two statements or sentences. Logical implication is a type of relationship between two sentences or statement. The relation translates verbally into logically implies or if then. Logical implication can be represented by this symbol, right? If then. Example, if you have two statements P and Q, if P, then Q. We can write it in a form of implication if P, then Q. And is symbolized by a double line arrow pointing toward to the right. So this is logical implication symbol, implies. And if A and B represent statements, then A implies B means A implication B. We can call it as A implies B. This is called as logical implication. Relation between two statements or sentences are called as logical implication. And if A then B, we can call it as if A, statement A, then statement B. The word implies is used in the strongest possible sense. So this is called as logical implication. So logical implication means it's a type of relationship between two statements or two sentences. So A implies B. A implies B. And here you have some problems. We are representing the logical implication here. I have one proposition. P implies Q shows that P and P implies Q implies Q. I have to prove this with the help of truth table. This is 4 marks question. So here we have to write the truth table for a given proposition. So already I have discussed so many problems on this. So P and Q, I have two propositions or two statements. First write all the truth values, true, 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 false, false, true, false and false. First find out negation P. P means it is true. Negation P is false. False, true and true. Negation Q is false, true, false, true. And what is P implies Q? You just check these two columns. P implies Q is true, false, true, true. Except this statement, all other conditions are true in implication. So now we have to find the final statement. P and P implies Q. Here we are using AND operation, that is multiplication operation. You just check this column and this column. In AND operation, if any one of the statement is false, so you will get the false condition. So true, true is true, otherwise everything is false. So here with the help of truth table, we can find the logical implication. Clear? And the second problem, P implies Q and negation Q implies negation Q. So find out with the truth table. false, true, false, false. So find out negation P, false, false, true and true. Negation Q. Negation Q is false, true, false, true. And P implies Q. P implies Q is all the statements are true except this true, false statement. So it is false. True, false means it is false, otherwise it is true only. Now find out the final statement. P implies Q and negation Q. So you have to use these two columns. So this is first column and this is second column. P implies Q and negation Q. So P implies Q and negation Q. So here we are using AND operation. If any one of the statement is false, so final condition also false in AND operation. So it is false, and false true is also false. False true is false, true true is true. So we are showing the logical implication. And the next problem, P or Q and negation Q implies Q. Again, first write the truth table, true true, true false, false true, false and false. Negation P is true false, true false, false true, false true. And negation Q, false, true, false, true. And P or Q, we are using OR operation, that is addition operation. P or Q, if any one of the statement is true, so your condition also true. So true, 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 false is last statement. And finally, you can find the statement of P or Q and negation P. So first you have to use this column and second column. So P or Q and negation Q, we are using AND operation, that is multiplication operation. So if any one of the statement is false, it is false, then it is true. False and false. So this is a truth table for a given proposition. So this is called as logical implication. So logical implication means the relationship between two statements or any sentences called as logical implication. And next important concept is rules of inference. What is this inference? Inference is called as deriving conclusions from evidence. What is this conclusion? We are deriving one conclusions from evidence is called as inference. So this is a definition of inference. Inference means deriving conclusion. Here we are deriving the conclusions. From where we are deriving the conclusions? So with the help of arguments, we are deriving the conclusions. So definition of rule of inference are the templates for constructing valid arguments. So what is this rule of inference? Templates is a templates for constructing valid arguments. So here in rule of inference, we are constructing the arguments. Rule of inference are the templates for constructing valid arguments. We are constructing the valid arguments in rule of inference. So what is inference? Inference means deriving conclusions from evidence. Clear? So we are using this argument. With the help of this argument, we are finding the conclusion. Clear? So definition is rule of inference are the templates for constructing valid arguments. And what is this argument? Argument is called as sequence of sentence or collection of sentence that end with a conclusion. Sequence of statements that end with a conclusion are called as argument. Example, if you have two statements P and Q, we are finding the conclusions, right? Whether it is P or Q or P and Q or P implies Q. We are finding the conclusions, right? We are finding the conclusions with the help of sentences or statements called as arguments. So when we can call it as it is a valid argument or invalid argument. So if you get a tautology, If you get a tautology, all the truth values are true, then we can call it as it is a valid argument. Example, if your P statement is true, then Q statement should be true or it can be false. But the final conclusions should be true. Then we can call it as it is a valid argument. So what is an argument? Argument is a sentence of statements, is a collection of sentence or collection of statements that end with a conclusion. Clear? So these conclusions are deriving from evidence. Clear? That is called as rules of inference. So you learned about inference, definition of rule of inference and argument. And the next topic is valid argument. So already I have told you about valid argument, right? An argument is said to be valid if and only if it is not possible to make all premises are true and a conclusion false. So what is this premises are true? Premises means, example, I have one statement P and one statement Q. So you are getting another statement, right? These two are called as premises. By using these two premises, we are getting the conclusion. This negation P is called as conclusion. Understand the concept properly. Rule of inference. This inference means constructing and deriving the conclusions, right? So deriving the conclusions means it is an inference. And rule of inference means it is a template for constructing valid arguments. So what is this argument? Argument means sequence of statements. And in valid argument, we are getting the premises are true. If your premises are true, so conclusions are true means that is called as a valid argument. Otherwise, it is invalid argument. And premises. What is this premises? Premises is a proposition on the basis of which we would able to draw a conclusion. Already I have told you about premises, right? So here we are drawing a conclusion with the help of this premises. This is called as conclusion. Therefore, negation P, right? This is one example I am explaining you. Here, therefore, I got negation P is a final conclusion called as it is a conclusion. If your conclusion is true, then we can call it as it is a valid argument. Otherwise, it is invalid argument. So, premises means the two statements. Two statements or number of statements is called as premises. Premises is a proposition on the basis of which we would be able to draw a conclusion. Clear? Conclusion means a proposition that is reached from given set of premises. With the help of this premises, we are getting the conclusion. Clear? These are the main concepts of rule of inference. So you can expect this question for 2 marks. So valid argument, invalid argument and the definition of premises and conclusion and what is argument and what is inference and what is rule of inference. These are the basic things first you have to learn in rule of inference. And the rule of inference are the templates for constructing valid arguments, right? How to construct the valid argument in rule of inference. Example, here you have P1, P2, P3 up to Pn are called premises. These are the premises of the argument and Q is called the conclusion of the argument. Example, if you have P1, P2, P3 up to Pn, these are the premises. With the help of this premises, we are getting the argument called as Q. Example, if your premises are P1, P2, P3, P4 and up to Pn, so your arguments are Q. If argument is Q. This is just an example I am explaining here. P1, P2, P3, P4, P5 up to Pn are the premises and you are getting, with the help of this premises, we are getting the conclusion called Q is an argument. Clear? This is a basic concept you have to understand. And what is the objective of this rule of inference? Here, with the help of this rule of inference, we are deducing logical outcomes. We are finding the logical outcomes with the help of this rule of inference. Example, if it rains, if your first statement is P, if it rains, P statement is if it rains, Q statement is I will get wet. I will get wet. I have two statements. With the help of these two premises, I can get the valid argument, right? I have two statements. P statement is if it rains. Q statement is I will get wet. This statement can also written with the help of logical implication. I can write this if it rains. If it rains means P implies I will get wet. If it rains, I will get wet, right? So this is called as P implies Q. If P, then Q. And the second statement is it's raining. It's raining. It's raining means the statement P. If it rains, that is the statement P. If it rains, I will get wet. The logical implication is P implies Q. And the logical implication for it's raining means the statement is P. So, we'll get the conclusion, therefore means conclusion, I will get wet. I will get wet means this is the statement Q. This is one example for rule of inference. So, we can represent this statement with the help of logical implication. Here, I have two statements. You just observe this example. Sometimes in exam, they will give the statement. Write the logical implication for this statement. So, how to write the logical implication? If it rains, that is the statement P. Then I will get wet. If it rains, I will get wet means P implies Q. And the second statement, it's raining. It's raining means the statement P. So, I have written P statement. So, what you will get? So, you will get the conclusion. What is the logical implication of this statement? If it rains, P implies Q. It's raining, it's P. And I will get wet. I will get wet means it is statement Q. This is called as rule of inference. So, we have different rules in inference. So, which are the rules we have to study in inference? This is very important rules. We should learn these rules for problem solving. So, first rule is rule of simplification. What is this simplification? Here, the rule of simplification, this is a name of the rule. So, first rule is simplification. The rule of simplification. First rule I am explaining. So, rule of simplification states that if P and Q, we are using AND operation, P and Q is true, then P is true. That is, P and Q implies P. If P and Q is true, then P is true. So, this simplification law states that if P and Q true, P and Q is true, then P must be true. Why it is true? You can use the truth table for implication. So, here if P and Q is true, then only the P statement also true in implication. So, true means true and true means we will get true only. So, if your P and Q is true means we will get the conclusion also true. Now, it is a valid statement. Please understand the concept. If your P and Q is true, then P also true. P and Q is true, then P must be true. I'll give another example for this statement. If your P and Q is not true, example, if your P is true, then Q is false, what you will get? You will get false condition, right? So, if it is false means P also false, it is not a valid statement. So, if P and Q is true, then P must be true. This is valid statement. So, how to write this statement in rule of inference? P and Q is true. P and Q is true. So, P must be true. Therefore, P must be true. So, P and Q, therefore, P. This is called as conclusion. Therefore, P is also true. This is conclusion. If it is both the statements are true, then it is valid argument. Otherwise, it is invalid. If you get false condition, means it is not a valid statement. It is very simple. Simplification rule states that if P and Q is true, then P must be true. That is called as simplification. And next statement is rule of addition. Rule of addition states that if P is true, then P or Q is also true. Or else you can give another statement also, true or false. If P is true, then P or Q is also true, because true or false is true. So, true is equal to true. It is a valid statement. This is called as addition, rule of addition. I'll repeat. If P is true, then P or Q, we are using OR operation. OR means addition operation. In addition operation, if any one of the statement is true, then all the statements are true only. If P is true, then true and true is also true, right? So, it is a valid statement. Or sometimes if you give true is false, then also you will get true condition only. So, true is equal to true. It is a valid statement. So, how to write it in a rule of inference? If P is true, then P or Q must be true. Therefore, the conclusion is P or Q. So, P means you can also written as it is P or Q. P or Q is also written as P, or P and Q is also written as this P. So, P or Q is also written as P. This is called as rule of addition. So, in rule of simplification, P and Q is equal implies P, and in logical addition, P or Q implies P. If P is true, P and Q must be true, and if P is true, P or Q must be true. This is logical addition and this is simplification in rule of inference. So, these are the basic rules I have explained. Next important rule is rule of detachment, is also known as modulus ponens. Modulus ponens is also known as rule of detachment. So, what is this rule states that? This rule states that if P is true, then P implies Q is true, then Q is also true. So, how to write it in a logical implication? So, this is a tabular form of this modulus ponens. So, what is the tabular form of modulus ponens? P and P implies Q. P is true and P implies Q, then Q is true. So, Q is called as conclusion. Q is called as conclusion. So, these two are the premises. So, this is tabular form of this modulus ponens. P and P implies Q are called as premises and Q is called as conclusion. So, how to simplify this rule? Here, P and P implies Q and conclusion is Q. So, this states that P and P implies Q. If P and P implies Q is true, then Q also true. Example, if P is true and P implies Q is also true, then Q must be true. Clear? So, here I am using AND operation. If P is true, Q must be true. Otherwise, in implication, what is the truth table for implication? True, true is true. True, false is false, and false, true, false, false, true and true. If you are giving Q is false, what will happen? If you are giving Q is false, so you will get false condition here. So, it's not a valid. If you get false condition, it's not a valid statement. So, if your P is true, then Q must be true. Otherwise, you will get false condition in implication. Clear? So, in implication, true, false means then only we will get false. Otherwise, all the statements are true. So, if P is true, then P implies Q must be true. Then Q also true. So, this modulus ponens states that if P is true and P implies Q is true, then Q is true. So, this is a tabular form. P and P implies Q. So, therefore, Q. I'll repeat. P and P implies Q. Therefore, Q. Therefore, Q means it is conclusion. P and P implies Q is called as premises. Please understand the concept. It is very simple concept. First, you have to understand the truth table for each and every proposition. So, if you know the concept of truth table, so easily you can simplify the rule of inference. So, here in every rule, we have logical implications and tabular form. So, if you are applying the truth table method, so easily you can simplify this. So, here in place of Q, if you are giving false, you will get false condition. So, it is not a valid condition. So, all the conclusion should be true in valid argument. So, here if P is true, then Q must be true. Otherwise, we will get false condition, right? So, true and true implies true. True implies true means what? It is true. So, true and true is called as what? It is true. So, condition is valid. So, first you have to practice the truth table. Please practice the truth table. So, easily you can simplify this rule of inference. And the next very important rule is modus tollens. Modulus ponens is different. Modus tollens is different. So, this tollens rule states that if P implies Q is true, P implies Q is true, then Q is false. Q is false means negation Q. If P implies Q is true means, so P is also true, Q must be true. Otherwise, we will get false condition. True, false means what? We will get false condition. So, P implies Q is true, then negation P. Q is false. Q is false means negation P. So, therefore, the conclusion is P is false. P is false. This is a tabular form of this modus tollens. So, again I will repeat. If P implies Q is true, P implies Q is true and Q is false, because negation Q I have, Q is false means negation Q, then negation P means it is false. So, true, 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 true means we will get true and false. True and false, we will get what? We will get false. So, this condition is valid because true and false. If any one of the statement is false in AND operation, you will get false condition, right? So, this statement is valid. So, how to write this in a tabular form? P implies Q and Q is false. And Q is false, then conclusion is P is false. P is false means negation P. If P is true means negation P is false. If Q is true means negation true is false. Please understand the concept here. With the help of this definition, we can write the tabular form. If P implies Q is true, Q is false. P implies Q is true, Q is false, then P is false. Clear? So, this is called as modus tollens. Dear students, this tabular form is very important for problem solving. Please remember this modus tollens, simplification and addition and modulus ponens. So, these are the statement tabular form we are using in problem solving. Clear? So, this is called as modus tollens. For every statement, you can find whether it is valid or not with the help of this truth values. Clear? So, you have to practice the truth table first. So, next statement is hypothetical syllogism. Hypothetical syllogism. Here, if P and Q is true, if P implies Q is true, if P implies Q is true, and Q implies R is true, then conclusion is P implies R is true. Listen, P implies Q is true, Q implies R is true. Conclusion, therefore P implies R must be true. Example, first I will write the statement here. P implies Q is true and Q implies R is true. So, it implies P implies R. If P implies Q is true, what you will get? You will get true. And Q implies R is true. Q implies R. True means you will get true. So, P implies R must be true. So, true and true means true. True is equal to true. It is a valid statement. So, how to write this in tabular form? Tabular form is P implies Q and Q implies R. Therefore, P implies R. If your P and Q is true, then Q and R must be true. Therefore, P and R must be true. This is the proof of hypothetical syllogism. And you have to remember this tabular form of this syllogism. Clear? And the next rule is rule of disjunction syllogism. This is another rule in rule of inference, disjunction syllogism. This rule states that if P or Q is true and P is false. P is false means negation P, then Q is true. So, this is tabular form of this statement. So, I will write the statement. If P or Q is true and negation P is false, then Q is true. I will write the truth values. P or Q is true and negation P means it is false. So, Q is true, right? So, true. True or true means what? It is true. And false. True and false means true and false. And operation we are using, it is false. So, it is not a valid because we got false here. So, if you are using true or false for first statement, true or false, it is also true. And negation P is false. So, true. Q is false. So, true or false is true. And true and false. So, what is true and false? We'll get false, right? So, true and false is false and false. So, this statement is valid. So, true and false also false and Q also false. So, true and false is equal to false. So, here P is true and Q is false. So, negation P is false. Then, therefore, Q is false. So, this is a tabular form of this statement. This rule is called as disjunction syllogism. Here, you have to apply the truth values to find the statement is valid or not. Here, I am applying the statement if P is true or Q is false, then negation P means it is false. So, the conclusion is false. Clear? So, the conclusion is false because Q is false. Therefore, Q is false. P is true. Q is false. And the next rule is conjunction. This conjunction rule states that if P is true and Q is also true, then P and Q is also true. I'll repeat. If P is true and Q must be true. In AND operation, if any one of the statement is false, you will get false condition, right? If P is true, Q must be true. So, true and true is, will get true. So, P and Q is also true. So, how to write this in a tabular form? P is true, Q is also true. Therefore, P and Q is also true. It is a valid statement. And the last one we have resolution. So, this rule states that P or Q is true and negation P or R implies Q or R. If statement P or Q is true, true or true means it is true, and negation P means what? It is false, or are also true. So false or true means it is false. So Q is also true or is also true. So true or true means it is true. So true and true is also true. Q or true is also true. So this is valid statement. How to write this in a tabular form? So P or Q is true, then negation P is false, or R is also true, then Q or R is also true. So you have to explain this with the help of this truth value. So then only you can understand the concept very well. This is called as rule of inference. So today you learned the basic concepts of tautological implication and the implications table and the rule of inference. So it is very important concept. Please understand the concept easily. You can simplify the problem in rule of inference. We have studied different rules in inference, that is simplification, addition, modulus tollens and modus ponens, and disjunctive syllogism and hypothetical syllogism and disjunctive and resolution we have studied today. In my next session, I will discuss some problems on the rules of inference. Thank you.